Hello everyone. I will use two videos to show how can we do the TCP IP communication by using Siemens S7-1200 PLC or S7-1500 PLC. When we are talking about TCP IP communication, there will be a couple keywords or terminologies. Firstly, OpenIE communication, or you will see Open User Communication (OUC), or the TCP IP communication. They are talking about the same thing. That means how can we use Siemens PLC to do the TCP IP protocol to do the communication. And I will use two videos to show how can we do this because it can based on two typical example program. The first example program that came from this ID number, and I will use this example TSendC or TReceiveC. And another reason I like to show this case because in this example, it based on the ISO on TCP communication. This example is not using TCP IP communication. You have to modify or configure something in the connection DB data area. You need to change some parameter. Second example, I will use this example. This is a very famous library. So the first one, LCOM. LCOM is one keyword terminologies from Siemens, especially if you are using TCP IP to do a very large amount of data communication. This LCOM library is highly recommended. So I will use this LCOM to show how can we do the TCP IP communication. I will use two videos. In this video, I will use this one. So basically, if you are using Siemens CPU communicate to another Siemens CPU, for example, S7-1200 CPU or S7-1500 PLC, 1200 PLC, they all Siemens PLC communication each other. Highly recommend you can use ISO on TCP. A common way if one Siemens PLC CPU need to communicate with other devices, for example, sensors or cameras, some cameras or some devices does not provide Ethernet IP communication or perfect net communication. So you have to use a common protocol, for example, TCP IP to communicate with them. Basically, the device or camera will run as TCP IP server, and the PLC side will run as a client, the active side. PLC will run as an active side. And the second common question, while we are using TCP IP communication, how large amount of data in one connection we can communicate? So I highly recommend you can read this ID number. And here there are three documents we can read. Typically, we can download this manual and this manual. For example, if you are using Siemens S7-1500 PLC, for the TCP IP communication, the data size could be 64 KB. Wow, it's very large. And more importantly, the connection numbers. So we will see typically above 64. That means one CPU, by using their integrated perfect net port, this one CPU can set up 64 connections. If you are communicating with one device, sending and receiving, you want to do the same time. That means you have to set up two connections to one device. So basically, at least this one CPU can communicate with 32 devices at the same time. So if you are using the S7-1200 PLC or some old style S7-300 PLC, you can download this manual and we can see. So in the past, a typical 300 PLC 315, it can communicate basically 1400 bytes. And the 1200 PLC, it can communicate 8K bytes, 8000 bytes, this TCP IP protocol. And this maximum numbers of connection, this is the 8. And the great things of using Siemens TCP IP communication, you do not need to set up any hardware connection, any hardware configuration. You just program and active that resources, connection resources, and here we go. Okay, so this is the connection resources and the data length, very important. Let's use this example, this ID number, and let's download this example. So this example is based on the ISO on TCP IP connection. We have to change this a little bit, but very minor change. And this OUC means Open User Communication, OpenIE communication, or we call it TCP IP communication. And let's shift to the TI Portal software. Okay, after we download this example project, we can unzip. And when we open this, we'll see this example project, it was using TI Portal version 15, but don't worry. So we can use the higher version TI Portal directly open this. For example, in this case, I will use TI Portal version 17. Okay, I will use TI Portal version 17 to open this project. Okay, after open the TI Portal, we can use the project open. And then click the browse and let's browse this project. So here, it was using version 15. Let's open this project directly. Okay, currently I'm using version 17. Okay, let's click this upgrade version 15 to version 17. And from here, we can see this example project, it provides 1500 PLC and 1200 PLC. So in this case, I'm using 1200 PLC. Program are compatible with 1200 PLC and 1500 PLC. So not quite matter which kind of controller you are using. Okay, in this case, I'm using 1200. I can open this device configuration. Okay, let's firstly change the hardware configuration according to your real hardware. Currently, I'm using 1214 AC-DC relay. So I can change the hardware and I can do the right click and click this change device 1BG40. Okay, and I can pick this hardware version 4.5 because my hardware, that version is version 4.5. Okay, and click OK. Change the hardware the same as the real hardware as you are using. And because I'm using version 17, so this TI Portal version 17 needs this wizard to go through this confidential PLC setting. So basically, I will open up everything. So do not protect this PLC, and I will allow everything, and I will do the full access. Okay, click OK, finish. And then double click this Ethernet port. So you can set the IP address for your PLC controller. So in this case, my PLC IP address is 1.174. Okay, this is my PLC IP address. And my PC IP address is 1.253. And make sure they are at the same subnet mask. Okay, so the PLC IP address is 1.174. To do the TCP IP communication, except this IP address, we do not need to do any other CPU hardware connection configuration. That's why the TCP IP communication here we called Open User or OpenIE communication. We do not need to do any other hardware connection configuration. And we can go to the OB1 main. And let's look at this example project. And when we open this, we will see, and the program style, it is using FBD. So this code, which is fine, but when we open this, we'll see the inside of the TSEND and TRCV. This style is FBD. If you are comfortable with ladder logic, so we can close it and we can change to ladder logic. So we can right click, click the properties, and we can switch to the ladder logic. Then the logic can automatically change to the ladder logic style. Okay, and go to the TSEND, go to the properties and change to the ladder logic. Okay, and double click the send. Okay, initially it has this red mark here. So don't worry, we can firstly compile this. Okay, we did some changes on hardware and this logic style, and let's see if the system can automatically correct this. Okay, there maybe has some inconsistent problem, but after the compile, the system can automatically correct that. So likely the system can correct that. Okay, so good. In this program, the key function is this network tool. For send, it is using TSend_C. So this function block came from the instruction. And if we go to the communication, open user communication, and we will see TSend. underscore C. So this function block is used to set up and establish a connection, also will send the data. So set up the connection and sending data, this function block does these two tasks. And TReceive underscore C, this function block also does two tasks, set up the connection and receiving data. Okay, so if we go to the receive, we will see the key function block. That's the TReceiveC. So using Siemens PLC to do the TCP/IP communication, this is a very common way because it's very easy. Send and receive, that's it. So the connection are built in into this send and receive. Another way, basically you need 4 steps. You need to do the connection at first, and then you need to do the send or receive. After you finish the job, if you need to disconnect the connection, you can do the T connection disconnect. So you need a 4 function block here. This is the typical 2 main ways to do the TCP/IP communication. Then let's review this example project. Let's go to the send. The send area, we can see it has this slightly logic here. So the detailed explanation, I highly recommend you better read through the manual. So if we go to this manual, don't forget this manual came from this ID number, okay? And we can review this manual. It only has 15 pages. Highly recommend you read the detail. So there are a couple spots I highly recommend you need to read the details. Firstly, by default, this example project is based on the ISO on TCP. So you need to take care, you need to change this style. For example, in here, in this connect, if we are using the ISO on TCP, the connection parameter, this data type, it will use the TCOM/IP RFC. So you will see the existing example project is using this data type. However, in this video, I'm going to show the TCP/IP communication. So we need to use this TCOM/IP v4. I will show how to change it. Okay. And other than this, we also need to review the configuration. For example, the length, system set 0. Look at this. If a send area with optimized access, then this length need to set 0. So what does it mean of this optimized access? That means for this send area, this send data, if we right click, go to this sending area, we'll see this DB, it doesn't have the absolute address. That's because this DB3 here, this is the one optimized DB. If we go to the properties, if we go to the attributes, so this is the optimized DB. In optimized DB, the data in the optimized DB, it doesn't have the absolute address. So all the things you have to use the name, okay? You have to use the name. So nowadays, all the common PLC logic, they are using the tag-based logic. So rare to see the absolute address. So this way is optimized. So we need to set 0 at here, okay? And then another parameter is very useful is this, CONT. This command is to control the connection. 0 is disconnect. 1 is establish the connection. When the PLC start up or recycle power, so the first things we need to turn on this connection. And after this connection established, then we can enable the receive. Enable the receive is basically receiving the data. But before we receive the data, we need to make sure the connection has been set up. Okay? So we can use the status feedback to check the connection status. Okay? And other than this EN and the CONT, there's another thing I like to discuss a little bit. In this manual, it doesn't explain, but if you click the F1 help, you will see this explanation, AD hoc. Let's click the function F1. Okay, when you review the help from the TI portal, you will see for the TReceive or TSEND, it has 2 sections for this help. So basically, we will select the second one because currently the CPU what I'm using, that firmware is higher than 4.0. right? So for this selection, the first one, that firmware is lower than 4.0. If you scroll down, so for the TCP IP, the 80 hawk mode, so it's only available for the TCP IP protocol firstly. And this is especially used for if the receiving area is dynamic. For example, in this case, I'm going to use one software socket tool to run as TCP IP server. Every time when I send the data to the PLC will receive the data. I will send a different length. So in this case, I need to turn on the 80 hawk. So this is the case every time the PLC need to receive the data dynamically. The length is dynamic. But if your PLC is communicating with another controller and both sides define the length is solid, is fixed, then you do not need to turn on this. But that moment, you need to change this length. For example, if both sides define we need to send 100 bytes, so you can set 100 at here. But if you are going to communicate with one PC, 90% the length is dynamic, so you need to turn on this. So in this case, I'm going to add one mode control for this 80 hawk also. So I'm going to open this generic data and also create one tag here, float it, and I will call that receive 80 hawk. Okay, this is the bool command. Let's connect to here. Okay, this is the 80 hawk. So again, you better review the detailed explanation from this manual. Also, anytime you have error from this test, you better check the TI portal help. Click the F1, then you can find this help. So, and especially if you scroll down, you will see those code. So those code is easy for us to troubleshoot and find out the problem. For this selection here, the COM IP is used for ISO on TCP. For the TCP IP communication, we need to change to this TCOM IP v4, enter. Okay, this IP TCOM v4, enter. Very carefully about this. And also, if we expand here, there are a lot of parameters at here. This is used for set up the connection for the send and the receive. So this too is very important because those are the parameters, so we better retain this parameter. For example, if we set up the IP address, this target IP address and the port number, so we better retain the parameter. So, and also for this connect, we turn on the retain. Okay. All right. Now let's drag this parameter to a watch list, so it's easy for us to do the online commissioning. Okay. So we can rename this watch list to TCP IP. Okay. And then I can drag all those things, connect, send those parameters. Okay. To here. And remote IP address. So let's drag this IP address to here. And the port is very important. Okay. Drag this connect, receive. Okay, connect, receive. Let's drag this, create a new line here. Let's call this is the receive interface, drag to here, and the remote address, drag to here. Okay, and a remote port. Okay, especially this port, I will explain this after. Okay, this is actually very important. Most of the cases, if the new learner try to set up TCP/IP connection wasn't successfully, 90% caused by this. Okay, all right, we prepare this, and also we will see in the OB100. OB100 is a startup. The moment when the controller just boot up, so the first run, it will run the OB100 program. It only runs one time, so usually used for the initial parameters. Okay, as we can see, when the system powered up, it will try to turn on the connection for the receive turn on and the send connection turn on. And also it will turn on this enable. If we go to the FC send, okay, this enable will control this. That means by default, the TSEND will not be triggered. But when the controller boot up, this connection send, it will turn on. So the system will try to set up the TSEND connection. Okay, and for the TReceive, we will also see here TReceive, COM receive, when the system just boot up, so this connect, this command will turn on. The system will try to set up the connection via this receive channel. Okay, the send and the receive, this is the individual two channels. Using this way, the send and the receive two channels will set up the connection respectively. Okay, then let's go to this watch list. So we definitely need to set up the parameter for this controller. Okay, so now let me firstly download this controller. Okay, let's download this controller. After the download, we can start up the controller and go online and let's set up those parameters at here. And this is very important. My PLC IP address is 1.174. Okay, so let's load the program. Okay, click this consider as trusted controller. Okay, because we are using the version 17, the version 17 need this security setting. Connect receive, they will turn on because this OB100. However, currently all those parameters still 0, so the connection is wrong. So we can temporarily ignore that. So let me click this go online. So importantly, we need to set up the connection parameter. So for this TSEND, let's focus on the TSEND. So firstly, this interface ID. The interface ID, that means which hardware port we need to use for the connection. So we need to go to the hardware and we click this port. We will see this system constants. And this port number, this port is this RG45 port. And this hardware number is a 64. So we need to set 64 for that port. Okay, so we can close it, go back to the program. And for this interface, we will set 64. Meantime, for the receive, we will use the same port, so we will set 64 also. Okay, transfer. And for the ID, for the send, we will use the ID number 1. And for the receive, we will use another ID. Basically, they are working individually. So for the receive, we will use ID 2. Okay, and the connection type. So the hex, that's the B. And if we switch to the DEC 11, 11 means TCP IP. Okay, if we review the manual, if we review this manual 2.6 for the TCOM IPv4, this connection, so we will see here, the connection type 11 means TCP. If for the UDP connection, it will select the 19. This is the decimal. So here we need to select the 11. Okay, and then for the next active establish, so we will select the true because currently for this mode, I will use the PLC running as TCP IP client to actively set up the connection with TCP IP server. So I will use one socket tool TCP IP software running as server. So in this case, I will set this active establish to true. To actively set up the TCP IP connection for send and receive both way, we need to do this active. This connection for the receive connection, by default, that is 11, no problem. And for this active established, we will select the true. Okay, so both sides we need to set active establish. Okay, That means the PLC will run it as TCP/IP client. Then the IP address, in this case, my target, the TCP/IP server, is my computer. So we will select 2 decimal. I can set here. Okay, my computer IP address 192.168.1.253. Okay, and for the receive, the same thing. So we will 1.253. Okay, same IP address. Okay, let's transfer. Okay, we transfer those parameters. And finally, the important parameter is this port. Okay, so in this case, again, send and receive, they are working respectively. So for example, for the remote, this PLC target remote, in this case, this remote port is my PC, my socket tool, TCP/IP server port. So I can set, for example, 2000. And my local port, this is my PLC. Okay, for send, I will set 3000. Okay, and then for the receive, we will use another different port. This you need to be very carefully. Most of cases, if people doing this test, if you set this remote port for send and receive as the same port, then when send and receive, they set up the connection, they will fight each other. Okay, this is very important. So we need to set a different port. For example, 2001, I will set for this receive area. And the local port for this receive, we will set a different parameter, so 3001. Okay, so this local port is for PLC itself. And this remote port is for the target. But for send and receive, they are using the different port number. Okay, otherwise they will fight each other. Okay, so let's transfer. All right, we prepare those parameters. And this is send and receive. So we can see this side. And if we go to the TReceive, okay, for the TReceive, there's another parameter, thot. So this thot I need to set to 1, so I can drag here. Okay, and I can set this to 1. Okay, I can turn down to true. Okay, after I prepare all those connection parameter, then we can toggle this connection. And then let's go back to the TSEND again. Okay, TSEND request, but TSEND request is waiting for this area. So we can see the TSEND request is controlled by this connect send firstly, and then it's using this 0.5 Hz. Every 2 seconds, it will turn on one time. It will trigger this request. Okay. Now we prepared all those parameters, and before that, and let's firstly turn this off. Okay, turn this off. Currently, I haven't set up the TCP/IP server side yet. Okay, the server side, I will use one socket tool. I will prepare this tool under this video, and you can download this tool. This tool named the socket tool is very convenient. Okay. Okay, this is this TCP/IP socket tool. Actually, this software can run as TCP/IP client or server or use the UDP communication. But in this case, we will test the TCP/IP server, this mode. Basically, this is the typical mode when a PLC need to communicate with the PC or SQL or any other devices. So basically the devices side will run as TCP/IP server side. And in this case, again, so from this setting, my PC, my computer is running as TCP/IP server, and the IP address is 192.168.1.253. Okay, and the port. So let's firstly test the send, this connection. So while we are testing the send, the remote port, that's 2000. This remote means this PC. Okay, so I will set 2000 here. Okay, and before we turn on this listening, so we need to temporarily turn off the firewall. Okay, let's go to the firewall and then go to this, turn Windows Defender, turn off your firewall. Okay, don't forget this. Okay, click OK. Okay, now we can test the send at first. So now for this send, I can also turn on this monitor. And firstly, I can turn on this connection. So let's start this listening. And now it's waiting for the connection. So from PLC side, let's turn on this connect send. Turn on this connect send. Let's turn on. Okay, turn it on. And then once we turn it on, because there has a logic here, now it's triggering this TSEND. And we can see, so currently the receive, we turn it off, but TSEND set up this connection. It saw this client 1.174. This is my PLC. And now it's receiving nothing because our sending area now is 0. So let's go to this connect send. Is this send the data here. So let me go to this send data. Okay, and we can drag here. We can drag couple data. So let's write here. This is the send. Okay. And here, when we send the data to a PC, this software is receiving the data as a string. So the letter base, so we will send a char. So let's switch to char. We select this chart. Okay. And then here, if we send A, B, C, D. Okay. And now let's transfer this. Okay, this connection, we turn it off because we have this setting here. No worries. So let's turn it on again here. We set up the connection again. And let's wait for a short moment. Okay, we can see. So it set up this connection immediately and then will triggering this send. So every time it triggers send, we will see it's keeping receiving this A, B, C, D. If now I send 1, 2, 3, 4. Okay, send. Okay, we disconnect. Sorry for this. So let's connect again. Connect. Okay, I'm gonna delete this area so it will not send any command every time we transfer the data here. Okay, 1, 2, 3, 4, right? So again, if I send this time X, Y, Z, O, W, okay, and transfer. So we will see X, Y, Z is keeping sending this value. Okay, this is send. Okay, we test successfully. Now let's turn it off. Turn it off. We disconnect. So once we disconnect, we'll see it will show server closed. And now we will test the receive. So I will close this software and reopen this software. Okay, select the server and the same IP address from this receive, this setting, this remote IP address. Okay, 192.168.1.253. Okay, and this time the port we will see for the receive, the remote port will be 2001 instead of using 2000. 2000, this remote port belongs to the send test. But now for the receive, we will set this TCP IP server side to 2001. Okay, let's click enter, start listening. Okay, let's open the FC receive and let's monitor it. Okay, I turn on this AD hoc, and this length is 0 as required. Okay, and now I will firstly turn on this connect. Turn on this connect, and let's watch this behavior, this response. Okay, we will see after 2 seconds. So it shows it got this new client 1.174 from the PLC. Okay, and after it set up the connection, we'll see this status shows 7004. Okay, and the 7004, if we go to the help, if we go to this TReceive help, we can check the 7004 means communication connection has been established. Okay, so in the real case, once you receive 7004, you can turn on this enable. That means we enable the data transfer. Before we enable that, now if I send everything, for example, XYZ, if I send XYZ, okay, the receive buffer will receive nothing. Okay, let's prepare this receive buffer. Okay, receive buffer, we will see this receive buffer is here. We can right click, go to definition, or let's directly open this receive data. This is receive data here, this DB. Okay, let's drag a couple data here. Okay, receive data. Again, I will transfer this to char, and let's drag it to char. Okay, so now let me turn on this listening. Okay, start listening. And now with this parameter set up, so let's turn on this connection first. Turn on this connection. Okay, we got this 7004 again, so it set up this connection. And before we enable this receive, let me send something. So we'll see. So let's check if this receive buffer can receive something. Okay, XYZ, for example, send, or AB, send. Okay, it cannot receive anything because we haven't enabled that yet. But here, if I enable, the moment when I enable, we will see XYZ and then AB. This receive buffer will show all the data we sent before. That's because the TCP IP, the socket, it can buffer the data when it wasn't be enabled. But when we set up the connection, actually the hardware socket area has been working. So when we send something, even the logic side, we haven't received the data to this buffer yet. But the hardware buffer is working. That's why once we turn it on, all those data can show up. But it will cause the problem that all the data will line up. So eventually the data will show very mess. So this you need to be very carefully. At the moment when you're ready to enable, you better reconnect. Because when we disconnect and reconnect, that moment all the buffer will be removed, will be clean. So let me try this time. So let's turn it off first. Turn off the enable. And let's turn it on. Disconnect. Okay? And we can wipe out all those buffer. Okay, I can copy paste, wipe out all those buffer. Okay, now I turn this buffer to 0. Now let's connect. 7004. So let's watch here. Okay, it got a reconnect. We can send something XYZ again. Send. We haven't enabled yet, but this time I will now turn on the enable. So I will firstly turn this off, disconnect, clean the buffer. And then if I turn it on, reconnect again, 7004, let's watch this new client show up. Okay, now if I turn on this, we haven't sent anything yet. When the moment I turn it on, we will see the buffer still 0. Now it's actually waiting for the new command. So this time, if I send XYZ first, send, okay, we'll see XYZ. Okay, this is I accidentally mess up here. No worries, I can delete this line. 0, 1, 2, 3. So XYZ. Okay. Then if I send 1, 2, 3, 4. So let's see if 1, 2, 3, 4 will be shown here or override here. So if I send, we'll see. Okay, this time correct. It always starting from 0, 1, 2, 3, 4. Okay, again, if I send, say, WYZ, send WYZ will override starting from 0. All data will be override. This is something we need. Otherwise, all the data, every time it just connect with the previous data, it will super mess. Okay? Also, need to be very carefully while we are communicating with this software, because the length is unpredictable, it's dynamic. That's why this AD hoc, we need to turn it on and turn on the connection. Okay? So this is a very typical receive. All right, we just tested the send and the receive respectively. But in the real case, we need to send and receive at the same time. So how can we do that, right? So this will be two cases. One case is if your device send and receive has a different port, like this case. For the remote port, for send and receive, typically the device will prepare two ports, one for send, one for receive. Like this case, we can do this test. Another case, if the device only provides one port, but you still need to do the send and receive at the same moment. How can we do that? The basic idea is, for send and receive, we can now turn on, enable the connection for the send and receive at the same moment. Basic idea is, we turn on the connect for send at first. When send complete, then we disconnect the send and then turn on the receive. This going back and forth. We need to do this send and receive alternatively. The key idea is the send and the receive cannot be on at the same moment. Otherwise, they will fight in this remote port, because at this moment, your remote port only has one number, one port. This is the two scenarios. Okay, here, let me show the first scenario. We have the different port respectively. So while we're using this software, how can we do that? Very easy. We just turn on 2 times this software. Okay, let me close this software. Let me reopen this software. Okay, I can open this software 2 times. All right, here, so one for the 2000. Okay, 192.168.1.253. Okay, and the port, I can prepare this port for the send, this channel, this 2000. Okay, for this server, okay, for the second, for testing this receive, I can set IP address 192.168.1.253. And this port, I need to set this remote port 2001. 2001. Okay, we start listening. And now we can turn on this receive first. Okay, we turn on already. We enable this receive connection. That's why we can see for this 2001, this receive, this connection, they got connected. Let's clean out something. After all, we reboot this software. So let me disconnect. We'll see it's reacting. That means actually it's fine, this client, this side, this connection. So let me reconnect again, reconnect. Okay, let's wait for this response. Okay, now 7004, and the software also find this channel connection. Okay, now let me enable the receive. And now let me send a new data. Let's say 1 ABCD send. Okay, and let me scroll down and receive. We'll see ABCD, and let's send 1, 2, 3, 4. Send 1, 2, 3, 4. Okay. Also, we'll see again. This is the chart. Actually, the data behind, if we switch to the hex, is showing 31. If you search the ASIC table, you will see 31 hex. That means this char, number 1. Okay, and A, B, C, D, this A for the word, for the hex, that means 41. Okay, if you find the ASIC table, you will find A, that means this hex 41. Okay, the receive is working. Now, if we go back to the send, and let's watch here. So currently the send, we haven't enabled that yet. Okay, disconnect. So if we turn on this connect, and let's watch here. Okay, we will see it connected, and this send buffer XYZW, it keeps sending. Okay, it keeps sending. In the meantime, for this receive channel, we can send the same thing. Let's see if they can work in at the same time. So for the sending, it keeps sending from the PLC to this TCP server. Okay, let's leave it there. It keeps sending. But for this receive area, so we will send the data from this software to the PLC. So we can send again. So RST, let's try send. So we will see RST. Okay, very quick. And 678. Send 678. Okay, it can receive. Okay, if we go back to the receive, we'll see the receive is always busy because we keep enable that. Okay, that's why it can receive anything when we send to this PLC. Okay, it can receive now, no problem. All right, this is the key idea when we're doing the send and receive at the same moment. Again, the port, they must be different. Otherwise, the send and receive will fight each other for this port. Basically, who will turn on the enable at first, who will occupy that channel, the port. Then you will find some cases maybe send successfully, but you cannot receive. Or some cases you can receive successfully, but you cannot send. That's the key reason you are using the same port. And for the PLC, it's the same thing. So for the send and receive, we need to use the different port. Okay, different port for the local port. 3000 for the send, 3001 for the receive. Okay. And again, so like I showed, I can disconnect this command, the CONT, to disconnect, release the resource and release the buffer for the receive or for the TSEND. So if in case your target for send and receive, they are using the same port. For send and receive, you cannot turn on this CONT for the send and receive at the same time. You better do a sequence logic, send, and once send complete, then disconnect, and then do the receive. Receive complete, then go back to the send again, doing this sequence. All right, this is the TCP IP test for this TSEND and TReceive. And this is a very important idea for the port and this connection parameter. Also for the receive, if you are communicating with one PC, this ad hoc is very important. You need to turn it on before you turn on this CONT, set up the connection. All right, that's for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.